I want to start off with a couple of videos here, but before we jump on the videos, what you're going to see in these videos is two distinct different ways that we get our steel. One is an integrated steel mill, and one is what's called a mini mill. You're going to see a video of an integrated and a mini. One of them is US Steel and one of them is SDI. And basic differences that you're going to hear about, and we can talk about them afterwards with some more questions, is your mini mill you're going to see use a lot more scrap, and your integrated mills are going to take the earth materials all the way up to making your steel. That's the easiest way to describe the two. Both of them do use scrap, but one really is taking it from the core, and the other one's taking it from the recycled stuff that we've got. That's your two basics, but I did want to throw a couple of this picture up here. You're going to see, this used to be the presentation. We've now got a video that will show blast furnaces, the scrap coming in, how the hot strip mill, oxygen going into it. And you're going to hear some terms like pickling, cold rolled steel, temper mill. You're going to hear a few of those terms. I just kind of wanted to let you hear them. You'll kind of know just that, hey, that's what I'm listening for. But you're going to see where they temper pass some product, where they cold reduce it, where they hot dip galvanize some stuff. And you're even going to see some painting on one of the mills in here actually integrating some paints. But that's what we're going to kind of just view on it. Where does our steel come from? That's what the first couple things are going to be right here. It's just basically that. So sit back and enjoy a couple videos here.
Few fireworks displays are more spectacular than the drama that is steelmaking. The story of hot metal and cold steel is fascinating from start to finish, especially when seen through the experienced eyes of United States Steel. For our company, the story begins with a blast. As rock explodes and the raw materials of steel are tossed from the earth. The rock is taconite, and the prize inside is crude iron ore. We get at it by grinding the rock to powder and separating the ore with powerful magnets. Then we form and heat the ore into marble-sized pellets that will later be converted to iron. From bituminous coal, we create coke to fuel the iron-making furnaces. We crush the coal, seal it in airtight ovens, bake for 12 to 16 hours, and remove it from the oven as solid carbon fuel. The fuel and pellets come together in the blast furnace, where we add just enough limestone to remove impurities. From below, a continuous blast of superheated air combusts the coke, intensifying the heat and changing raw materials into molten iron. Sometimes more than 9,000 tons of it a day in our largest blast furnace, where it reaches a temperature of 2,700 degrees Fahrenheit. At regular intervals, we tap this blistering brew into giant submarine ladles that ride on rails to the basic oxygen shop, where iron will be turned into steel. In this fast-paced sequence, up to 250 tons of steel can be made to order in less than 45 minutes. We begin the steel-making process by dumping recycled steel scrap into the basic oxygen furnace and adding hot iron. Sparks steal the show when high-purity oxygen is blown into the mix at supersonic speeds and molten iron becomes molten steel. Now we're ready to create the custom blends that make steel the most widely used metal on the planet. In fact, we produce over 1,500 different chemistries to meet customer demand for cutting-edge, value-added steel. Look for another show of sparks as we tap molten steel from the Bop vessel into a ladle. Then, for most of our steels, it's on to the vacuum degasser, where they are made highly formable. The focus then shifts to forming and finishing, which determine even more of the steel's characteristics. The first step in this sequence is to position the ladle above a massive tundish or funnel that feeds a continuous caster containing molds that shape the steel. The molten steel, now at 3,000 degrees Fahrenheit, is channeled from ladle to tundish to caster, where it cools to a red-hot solid. The shape of the mold determines the shape of the semi-finished products that come out of the caster. And since most U.S. steel plants make sheet products, most of our casters output slabs, typically 8 to 9 inches thick and 3 to 5 feet wide. As they exit the caster, slabs are cut into sections up to 40 feet long and stacked to await further processing. Then it's on to the hot strip mill. This is where we begin transforming steel slab into steel sheet. Slabs are reheated to 2400 degrees Fahrenheit and descaled before running through a series of roughing stands that make them thinner and longer. Then they cycle through finishing stands where they are rolled even thinner. Finally, they are cooled and rolled into coils that may be thousands of feet long but only fractions of an inch thick. A far cry from the chunky rectangle that came out of the caster. And the entire process is untouched by human hands, controlled instead by operators using state-of-the-art automated equipment in pulpits that overlook the action. Next, we move to the pickle line, where coils move through an acid bath that cleans the surface. Some of the emerging coils are shipped directly to customers as hot band. Others are destined for applications that require special finishing, beginning with cold rolling to make them even thinner. At that point, coils may be shipped or go on to one or more additional finishing processes. Coating to make the steel resistant to corrosion. Tinning to further reduce the gauge and add the tin coat we commonly see on canned goods. Annealing to make steel that is easier to bend and form. And tempering that uses special rollers to add hardness and create surface textures and other special finishes. In fact, many of our products leave the finishing facilities as the industry's newest superstars. Lighter, stronger, highly engineered, formable steels that were unheard of just a few short years ago. No wonder the story of steelmaking stays so fresh, with innovations that guarantee something new to see in each showing. With product placements in our homes and high-rises, on our highways and in every other part of our daily lives. And with a cast of thousands who continue to improve and perfect every step of the steel-making process, from shaped pellet to shipped coil and beyond.
Mini mill or integrated? Integrated, why is that?
Blasting, taking the raw materials.
Raw materials all the way from the earth up. Yes, very much so. Then the next one we're going to look at here is another company, SDI, which we get our mini mill.
Steel Dynamics is a leader in the mini-mill steelmaking industry with a focus on value-added products with demanding quality requirements. And at the heart of the mini-mill process, a more environmentally friendly way of making steel is scrap steel. Lots and lots of scrap steel. In fact, about 75% of the material SDI uses to make new prime steel consists of scrap steel that is often left to rust in junkyards or litter the countryside. SDI also owns OmniSource, the second largest scrap recycling company in North America. And that's where our story begins, at an OmniSource facility in Indianapolis. OmniSource collects and processes ferrous scrap and non-ferrous scrap at more than 70 facilities around the country. Here at one of OmniSource's 5 facilities in Indianapolis, A gigantic shredder reduces entire automobiles and other large pieces of scrap into smaller sections that will fit into the flat roll division's electric arc furnaces. After the scrap is shredded, giant magnets separate the ferrous materials from the non-ferrous. Non-ferrous scrap is conveyed away for further sorting. Just as in the mini-mill steelmaking process, nothing goes to waste. At a visual inspection checkpoint, employees remove any non-ferrous scrap that's hung up with the ferrous material. Next, the scrap is shipped to the Flat Roll Division's mill at Butler in northeast Indiana. The mill campus includes 15 miles of railroad track capable of handling 700 rail cars at one time for incoming scrap and outgoing steel shipments. The mill also receives 200 to 300 truckloads of scrap and other raw materials every day. It's a 24/7 operation that runs 365 days a year. 3 30-ton scrap cranes and large front loaders facilitate moving the scrap around, in and out of rail cars and trucks, and to the scrap bay at the edge of the melt shop, where large magnets lift up the scrap and place it into a charging bucket. Scrap is loaded into the charging bucket according to grade to achieve the exact chemistry necessary for our steel products. Each furnace heat consists of 175 tons, with at least 75% of it scrap, and about 10% liquid pig iron from Iron Dynamics, a division of SDI on the Flat Roll Mill campus. SDI is also making iron-rich units with a pioneering process at Mesabi Nugget in Minnesota. Both IDI and Mesabi use iron-making methods that are far more eco-friendly than traditional blast furnaces. Mini-mills use electric arc furnaces, or EAFs, which require much less in the way of natural resources versus traditional blast furnaces. For every ton of steel produced by SDI, we eliminate the need for 2,500 pounds of iron ore, 1,400 pounds of coal, and 120 pounds of limestone. And we use significantly less energy in the process. The EAF process also produces 67% less carbon equivalent emissions. In addition, 95% of our scrap comes from within 250 miles of our plants. The charging bucket is moved to a position directly above one of the mill's 2 twin-shell EAFs. The scrap is then released into the furnace, creating some real fireworks. The reason for the explosion is that a portion, about 40 tons, of each heat of molten steel is left in the furnace to keep it hot for the next heat, saving time and money. Once the scrap and pig iron are loaded, the roof of the furnace is closed, and 3 large carbon electrodes are lowered through an opening in the roof. Then, it's showtime. And it's loud, very, very loud. The rods circulate or arc up to 115 million watts of electricity to melt the scrap at a temperature reaching 3,000 degrees Fahrenheit. The power is on for about 35 minutes to complete the melting of each heat, which is a good reason why our monthly electric bill is about $7 to $8 million. Once a heat is completely melted, the furnace is tipped to pour off the slag, a collection of impurities that rises to the top of the heat. The molten steel is then tapped through the bottom of the furnace and into a ladle. The steel then goes to the ladle metallurgy furnace, or LMF, where a variety of processes can be accomplished, including desulfurization and deoxidation. The temperature of the steel can be adjusted with carbon electrodes, and the chemistry of the steel can be changed by reducing some alloy elements and the introduction of others. From the ladle metallurgy furnace, the steel goes to the thin slab casters. On the caster deck, the turret rotates to exchange an emptied ladle with another ladle filled with molten metal. As it goes through the casters, the molten steel, now about 2,800 degrees Fahrenheit, is converted into a continuous ribbon of steel approximately 60 millimeters thick and up to 180 feet long. These thin slabs can be rolled into steel sheet much more quickly, efficiently, and cost-effectively than the much thicker slabs produced at traditional integrated steel mills. Producing slabs up to 64 inches thick, the casters operate at maximum speed of 230 inches per minute and process 9,000 tons of steel in a 24-hour period. Going through a 2,400 gallons per minute spray of cooling water, the slab is completely solid in 24 seconds and has an exit temperature of 2,100 degrees. After being sheared to length, the slab goes through one of two tunnel furnaces where the steel is reheated to 2,150 degrees before going to the hot strip mill. Scale is removed from the slab before it's rolled, with water jets spraying 4,000 gallons per minute at 3,500 pounds per square inch. Slabs are reduced to meet customers' requirements on our 7-stand hot rolling mill. 7 10,000 horsepower motors drive the work rolls in the mill stands, and 4,000 tons of rolling force per mill stand reduces the thickness of the material to as little as 1 millimeter or 0.040 inches. A new hot band of steel is automatically coiled. On average, each coil weighs about 22 tons, or as much as 10 cars. In the cold mill complex, coils are chemically cleaned through the continuous pickle line. Operating at 700 feet per minute, the pickle line has the capacity to process 1.6 million tons of steel annually. Pickled and oiled coils can be sold as finished products, galvanized on the hot rolled galvanizing line and sold as finished products, or further processed through the cold reversing mill. Hot band is uncoiled on the reversing cold mill, where the gauge will be further reduced to as light as 11,000ths of an inch. Coils that have gone through the reversing mill are usually galvanized or annealed. On one of our 2 galvanizing lines at Butler, an employee removes the dross, or impurities, from the surface of a zinc pot holding as much as 180 tons of molten metal. SDI's galvanizing lines offer a variety of value-added services, such as inline temper passing, tension leveling, chemical treatment, acrylic coating, and oiling. Annealed coils go through the temper mill and are sold or painted on our coil coating lines. Here we are on the banks of the Ohio River in southern Indiana. Jeffersonville produces hot-dipped galvanized galvalume, acrylic-coated galvalume, and acrylic-coated galvanized steel as wide as 61 inches. In fact, SDI is the only company in North America to make galvalume in widths wider than 50 inches. Before being introduced into the main pot containing galvalume coating, an aluminum zinc ingot is melted in a pre-melt pot that flows into the main pot to maintain a more consistent temperature. Here, a coil of galvalume is checked for surface defects. Jeffersonville is also home to one of our 2 state-of-the-art coil coating lines operated by the Flat Roll Division. The coil coating lines at Jeffersonville and at Butler give the division a capacity to paint approximately 500,000 tons of steel each year. SDI's Flat Roll Division is the only steel mill operation in the United States that paints its own steel. The 8-story accumulator unwinds a coil, allowing faster continuous coating. Some coils of thinner gauge steel would measure as long as 5 miles if completely unwound. The coil coating line has 3 coaters, 1 for primer and 2 for the top and bottom finish coating, making quick color changes possible. These lines have the most state-of-the-art equipment in the industry, including vision technology, producing the highest quality pre-painted coils available in the world. Whether coils are coated at Butler or at Jeffersonville, the highest standards of quality are maintained through continuous monitoring with leading-edge technology and equipment and well-trained eyes. We recently installed equipment that allows coils to be placed on pallets. Coils placed on pallets are easier to handle for our customers who depend on forklifts to move materials in their facilities. Coated coils are staged for shipment to our customers in a broad range of industries who use our steel in a wide variety of applications. Scrap produced during processing at Jeffersonville is loaded for shipment back to the Butler Mill, where, you guessed it, the scrap will be melted and used again to make new steel. It's a full circle.
What's the big difference there in the two mills?
Fresh and scrap.
Scrap? How much scrap, did you catch how much scrap was
Wow.
used?
29%.
How much?
75%?
75%. That's a lot. That's a lot.
What's the other 25?
The different stuff they were talking about has to go into it to make it back up. And they're adding other stuff to get the correct product that we're needing to it. But the other one you saw, they did a little bit of scrap and just nearly not much. How about the $8 million electric bill? Now, talk about the two mills really quick. Which one's kind of set up to be more environmental friendly?
The second one?
The second one, why is that? Recycling's a big one. What else is it doing?
It's electric.
It's electric.
Less resources.
Less resources. Which one has a bigger effect whenever scrap prices go up or down? The second one. And which one has more effect whenever the core earth stuff goes up or down?
The first one.
So there's some definitely differences in the two, but kind of a neat video to give you kind of an idea. Has anybody been to a mill like that at all? Have you been to one, Andy? It's definitely a good video that puts it all together. There's a lot of equipment there to get our steel to us. Well, what does make up our steel? Our steel basically has 8 layers. The raw stuff you saw them producing is your, where's the steel? Right here is the steel. That's the raw stuff. And then we come and you saw them in that one line where that guy had that ladle in there pushing the zinc and the aluminum and stuff like that around. That is either putting on your galvanized coating or your aluminum coat or your galvanum coating. And we'll talk a little bit more about that. So that's the coating that goes on top, and that's used to protect your steel from rusting. Then you've got a pre-treatment, you've got a primer, and then you've got paint. And we do both things on both sides. Some thickness differences on that, but you have both sides have that many layers going across them. That's what our steel is. What we buy for the most part, we do buy a lot of galvanized too, but in our most core product, we buy galvanum. What's galvanum made of? 55% aluminum, 43.5% zinc, and 1.5% silicone. That's what makes that up. And the silicone has a small impact on the nature of the coating. I got one of these I could use. This is a video. This is a little screen. I don't know if y'all know. This has been around for a while because it's very confusing to understand coating weights and the weight of our steel. Some of our customers will say, "Well, you have the same product, but yours is so much lighter. Why is it lighter? Why is ours heavier? This is a better product because it's heavier." Well, is it? And this is what we're going to try to explain there. Some of the products we carry are G40 coating, which is a galvanized coating. Some are G60. G90 is what we do on the Brilliant type product, and some of our other locations use G90. And then our galvanum is an AZ50 or AZ55. What does all that mean? This picture, it's kind of hard to tell because if you don't notice this, these thicknesses are the exact same all the way across. They're all, for this example, is an 015. But it looks like it's different sizes because your steel is different. And if you're going to maintain an 015 thickness, you're going to have different coating weights. So you have the raw steel, and look over here on this G40. How much coating weight are you getting on there? 0.007. So it's not a lot, is it? Your coating's going on there to keep from elements from deteriorating, like rust. So that's why galvanized is on there, to keep it going from the raw steel. Most of y'all, some of y'all are younger, but cars, you see cars on the road. Used to buy a new one when it rusted out. It just rusts through. Have you ever seen that where the car just rusts all the way through and you got holes and falling apart, the floorboard's falling out? The old cars used to be that way. That's what this is, the same product in here, is steel. But now they've developed coatings that go over it to help protect that steel. So as you see going to a G60, it's more coating. which in turns, there's more protection. It should last longer, should go longer. G90, we're moving on up, but look what's happening. The steel, the actual raw steel, is getting thicker, or thinner, but your coating's getting thicker. Which do you think weighs more, the raw steel or the coating?
Steel.
The steel weighs more. So as you put less steel but more coating, and still getting 0150, what's going to happen to the weight of your panel? It's going to get lighter. So look all the way over to where you get an AZ55. That's an aluminum, galvalume, which is going to last longer, perform longer for you. We'll talk about that in a minute. But look how much less raw steel is on that, just to get to the same thickness. There's your weight difference when you have the exact same thickness of an 015 G40 and an 015 AZ55. You will have a weight difference.
And
That's a little bit confusing, so I think this chart just kind of shows people. Now, is the customer getting the same product? I mean, the same quality product or same thickness of product? Yes, they are. And they're actually going to get more protection with this one. But some of the old timers think, well, it's lighter. How can it be lighter and be better for me? That's why.
oh, go ahead.
Go ahead.
Oh, the AZ55 is the acrylic.
That is the
Right,
acrylic.
We don't paint over AZ55.
We don't. We paint over AZ50.
Okay.
That's correct.
Yeah, none of this is including the painted coatings. This is
None of
strictly the galvanized or
That's
or galvalume. Now, in terms of as your steel's getting thinner and your coatings are getting thicker and you're getting a better protection of this for the steel, but are you seeing differences in rigidity? Are you seeing differences in?
You can.
Yeah, I mean, so for the contractor, it's not only going to be lighter weight, but it's going to be more flexible, maybe?
Can be.
Okay.
Can be. And all that's going to come back to, if you're using it for like engineering,
Right,
it's going to be what your product is and what it's made for.
right.
So that will make a difference. That can. Somebody who's got over here can probably go thinner, stronger, but is it going to last?
Right.
And that's where the payoff is, and that's where the differences have to come in to find out where that goes and where it comes from. A lot of this type of stuff, go down to your G40, is usually shade and shelter type stuff, where it's going to be out in a place where no one really is going to be high visible of it. It's going to break down quicker than the other ones. It's going to have rust quicker, but it's usually a farm or an old corrugated type setup. Over here, you're pretty much not going to stick on the front of a brand new Ruth Chris Steakhouse a G40 product. They want it to last and look good. They're going to put something that's going to last them longer. So there is differences, and that's where architects have to take in. Usually if your architects are involved, they're looking at long term.
Right. Another question, at the same thickness all the way across,
Uh-huh.
so all things equal, is there a difference in roll formability for these different types of products?
There can be. It depends on, now, you're getting to technical questions here
Yeah.
of what hardness of that product it
Okay.
is, and that can be a difference.
So
And
it's
that's
not-
going to play a bigger factor in it.
So it's not just the thickness of the steel, it's what kind of steel we're
There
actually
you go.
talking about there.
There you go. It gets to a lot of different things. So some of the competition that might use this might not be using the same raw steel. So there is some other factors in there. So that was really just put up there to let y'all to understand the difference in coating weights and what that does. But a very good point. Oops, not working now.
Get too far away.
So galvalume versus galvanized. We're saying galvalume is better. Why is it better? Here's some examples, and we're not going to go into a whole lot of details with this, but if you look over here, the galvanized sheet is this one right here. A galvalume sheet is this one. As you can see, this one's saying over years. This one is having a breakdown. We're going to see a couple pictures here in a second, but this is showing where the testing show your galvanized sheet's going to have more corrosion over time than your galvalume is. And on your right over here, it's got actually the galvalume in the green and the galvanized in the blue. And the reason we put that picture on here is these questions come up quite a bit. Well, how come how come there's different things going on? What's going on? What is this? What is that? Well, they actually classify these, and there's more classification than this, but these are the basic ones. They classify things as severe marine, industrial, and rural. And in those, you've got different products that across the board will have different lifespans. So they have to basically determine what those are. So severe marine, you might know what severe marine would be? Salt water, next to oceans. In that area where they're getting spray, they're getting all kinds of stuff. And salt is a very highly corrosive on product. The next one that just says marine, what would marine be?
Boat dock or boats.
Lakes, rivers, things like that. And you can see there's a big difference in the life of that product, huge difference. And many warranties will or actually probably almost all warranties will determine marine. We found out recently in a meeting that some of the foreign stuff coming in, when it says marine, or the marine side of it, they mean any water. And ours is, we've got a saltwater one versus that one. And there's some differences. Some people play with those warranties and what comes out. But for our purposes, we're classifying the severe marine meaning your salt waters, your marine being more of your rivers and lakes. And then you got industrial. Industrial would be like what? What would industrial be?
Storage.
Storage?
Storage.
Not really for that. Maybe it depends on where it's at. What's around an industrial? What's an industrial? Manufacturing. Has a lot of emissions, a lot of things coming out that have provide different environments around it, and those are a little bit more corrosive. But a mini storage could be in one of those areas. And then you got rural. What's rural? Farms. You got less of all the other factors there. Some of them have ponds and stuff, but for the most part, you get less of the corrosive side. So that's where they're showing lasting longer. Now, why is the top two up there? You see kind of not really finished up, and it says projected. Why would it be projected? You might know.
Depending on the weather elements and stuff, such.
No?
No?
Close, but no. We haven't had that long. Hadn't been out that long. So that's their projected how long it's going to continue in those environments, but they haven't, it's been tested through testing, but not actual live testing yet.
Yeah.
So it's not really, can't really say it's 100% gonna do that, because they haven't physically been out there that long.
Simulated.
Well, I'm gonna go to this thing. All right, now there's a couple pictures we're gonna see in a minute, but I want to point this one out. These little green triangles down here is representing our galvalume. The red is representing a galvanized product, and then the bottom is the number of years out. If you'll notice, which one is showing to have rust quicker? Galvalume. Whoa, what's going on? We just said galvalume is a better product, but it's rusting quicker. You might have any ideas why that is?
Is that the head rust or the?
It is.
Yeah.
It is. What happens is, and we're going to move forward here. I didn't know if anybody knew kind of a way to explain this. Talk about the old rusty panel. The galvanized product, it's a coating on top that's basically helped to protect the steel. But once something breaks through that coating or gets down to your raw steel, it can't stop. It just keeps growing. The rust will grow and grow and grow and grow. On galvalume, for a generic term, don't take this term and run with it, but a generic term, it's got a self-healing process to it where it protects itself even once something like this starts. It actually grows and protects your steel. So you're going to see this is called what they call edge creep on the edge of a steel. Well, what happens is that edge is someplace it gets cut. Where does it get cut at? Right out the door. So what's exposed? A raw edge. So once that raw edge starts, it kind of starts, and that's it basically self-healing itself over top of it. So it happens pretty quickly. The galvanized is happening underneath the steel and it's rusting away. And that's where you see it turning to this. This is this is a 20-year, the other one's a 21-year panel. What's happening to that product? It's falling apart. It's coming off. So a lot of times, if you'll go out and look at one of our new buildings, you're going to go over a year, a couple of years later, you're going to start seeing a little bit of that almost looking, it almost looks like mold, doesn't it? Like a black mold almost starting. That's the edge creep beginning, and it's starting to take care of itself. On the other product, it's not taking care of itself. It's continuing to get worse and worse and worse. So over time, your galvalume is going to outperform, and that's back to this chart here. As you can see, over time, it's outperforming itself versus the other. But in the beginning, and when we started using this product, using it pretty regularly and selling it years and years and years ago, we had a lot of people going, well, look at theirs, it's rusting. That was a big thing for the market, wasn't used to it yet, didn't know a lot about it. It's something that was something we had to sell against, and now it's become a more prevalent product.
And that's why they came up with galvalume,
That is why they came up with galvalume.
because of because they want to make the steel last longer, so they.
There's actually other products that are already come out with, we're working on to make it even better than galvalume. Of course, that's part of their industry, is to keep making it better and better and better. And that's some reasons our warranty's getting out there. Now, some big difference, painted galvalume. Do we have just a paint warranty?
Steel in.
We have a steel warranty too on the substrates. What about G90? Do we have a steel warranty and a paint warranty? Nope. So nobody will warranty galvanized, the substrate, but they warranty the substrate on galvalume. So the big difference is, let's say you've got a great big building out there and you've got I'm gonna get the warranties wrong, so bear with me, but a 40-year warranty on it, and you walk out there, it's competitors on this building next to it, and yours is right here, and theirs is galvalume, or galvanized, yours is galvalume. Go out there, paint company looks at it and says, why is the paint coming? Well, it's not the paint problem, it's substrate's got a problem on it. Well, both buildings have the same thing going on. So then, what comes out next? Your steel manufacturer. They come out and look at it, oh, man, it's galvalume, that's the problem. There's the warranty, they take care of it. The competitor, ooh, it's substrate. Sorry. They walk away. It's not a paint problem, so we don't warranty the substrate, they're off and they're gone. That's one of the ways we always sold against it too.
Now, does the warranty on the 40-year warranty galvalume, does it specify anything about the edge creep? Or does Greg have to go to every one of them guys and go?
No.
Standard.
No. That's a good question, Andy. I don't remember off the top of my head. I really don't. But he doesn't. There's times that we get calls on it, and I believe if you go and power wash that side, it comes that blackness stuff pretty much comes off. But I don't know if the warranty addresses it or not. That's a good question. I don't.
Did you say power wash it? Okay.
Some of them do, and it'll come pretty clean from that.
Yeah.
Because it's basically a residue that it's building up there. It almost looks like I said, like a mold coming on. It's not mold. That's a good question. Let me look that one up, Andy. I'll get back to you on that one. So our galvanized. Let's use this for an example. We've got your galvanized coating, and you got your steel strip. Well, something scratches it. Tree branch, somebody's gun from their screw gun, no matter what. Kid comes by, hits it with a bike, I don't know, that breaks that coating off, and it leaves your steel strip, your raw steel exposed right here. So in the galvanized, what happens? Right there. Starts rusting. That's your exposed point. That starts rusting. Now, will it just rust that spot when it gets down to the raw steel?
Keep going.
It's going to keep going. And that's some of the protection. Now, look at the galvalume, same thing, we have a scratch. This one's all galvalume, get the strip. When it scratches, look what's starting to happen right here. It's starting to protect itself. That's what the blue is coming back in. And you've got corrosion right there, but it's stopping it. It's taking care of it. And that's where, if that holds up like it's supposed to, it's taking care of your panel, and you're creating less decreased product over time. Now, if it really is a big scratch and gets down to the raw steel, is that going to be able to protect it? No. So it is a protection, but there is also some limits that it can do. Andy, you probably know this one. How do we order steel?
Min or non?
Min or non. So minimum is a number that we give them. Let's say a panel's 015 min. That means that we don't allow the mills to drop below that 015 at all. If they drop below it, what happens? We reject it. We had that happen recently. And we had, how many hundreds of thousands of pounds was that?
That West Coast stuff?
Yeah.
7 million pounds.
There you go. 7 million pounds came in underweight. It got rejected. And now we bought it as less cost and for a different product. But for what we were buying it for, it wasn't good enough. So there's a minimum, and typically these mills don't try to hit right at minimum. They try to go a little bit above so they're not having this issue. Because inside of our panel, if you know this, it's going to have what they call a crown in the middle. It's going to be thicker in the middle than it is on the side. Now, we're not talking tremendous amounts, but it has a crown in it, and it's going to have some different thicknesses. So they measure that from the crown, the center of the crown, out, because your outside is going to be a little bit thinner, typically, than your middle. And then nominal. So like our purlin, we buy our purlin in nominal, and we buy like an 059, 069, 099. That's the area they're trying to get to, but we actually have percentages above and below that they can go. So we buy it an 059, I believe it's an 055 is the minimum that they can actually come into. But it's a percentage of that. And they do that differently with different products. And the tolerances are different, but it also makes a little bit difference when they go to engineering, because different specs have to be made on minimum versus nominal. So they build their minimums on different for nominal than they do minimum. And a lot of it, it's really preference of what you do. Like on purlin, we could buy it 055 min, and it's going to be, or we buy it 0599. There's different pricing too with those two, because there's a little bit more variance the mills can do with a nominal than they can a minimum, because they know it's got to be this high. The pricing does make a difference on that.
And how do we QC that to know that something's in or out of spec? Do we weigh them in when they come in? Is that how
Well,
we know?
first of all, they have to give or they provide us a spec sheet of what their technical machines, like you saw them in that room on that one, all the data that's coming through. That's one way.
Okay.
On purlin, for example, when they come into a processor to be processed, they actually mic each one of them that come in to see if it's in there. Now, we've got a few recently that didn't hit and they've rejected it. So some of that is that. We do mic some here. I think y'all have seen us mic
So
some
one
here.
example from each truckload, or every coil?
It's not every coil. It's,
Yeah.
Does it be under every coil, y'all know? I don't know.
That would be a lot.
I don't know if he does every truckload or every coil.
It
He
seems-
does mic pretty often though.
Yeah, it'd seem like it'd be a lot if you did every coil.
Well, talking about thicknesses, this is a chart I'm going to throw up here. There's not really a standard. This is what's called the Canadian Sheet Steel Building Institute. Gauge numbers are not regulated and are generally used for convenience in sales literature. Decimal thickness is required for structural design. So, the competition's out there saying, hey, our panel's an 0145. It's a 29 gauge. Okay? What does that mean? We have some guidance from this type of thing that says, that's right, that's okay. What if they say it's an 025, it's 29 gauge? Well, there's no agency that comes out and regulates what you call something in the US. So these are guides, but you gotta have some kind of guide for structural design. But you might have people playing that game of what's the thickest, what's the thicker side, what's the thinner side. There's no standard of saying like 015 is 29 gauge, or 014 is 26, is 20, maybe 30 gauge. So that's something that I just want to make sure that we portray in here. We do have some guides that we all go by, or that we go by, but it's not standard. It's not a standard regulatory agency out monitoring that.
Who is that guy that comes and asks for poll tags for Mary Ann?
That is your, that is going to be your guy on all your, oh, what's that? From for Andy.
What is it now?
He UL, all of our UL ratings and stuff.
Oh, I know.
Those have to be to make those ratings that we're offering, but we're saying we're going to do that. And he's checking that.
Okay.
But let's say XYZ roll former down the street wants to roll a 014 panel. If he doesn't have UL, there's nothing regulating what he's doing.
Right.
That's why.
Okay.
Those certificates that we pay for to put out there are regulated
Okay.
for those type of classifications. All right. So talking about us and our competitors, this chart's really old. It's been around for years. I think we developed it years ago. So this is what generally we've seen in the past. I don't know how current this is. I just want to make sure I say that. Our thickness, steel with coating, we're saying almost for a prime is about an 0155. Our competition, one time that we did all this study, was an 0145. Paint thickness, 00135, same for both of us. Total with paint, 01685 to 01585. That would mean our steel is 6.9% thicker than that competition. So what does that do for it? Why do we do that? Anybody have any ideas?
An edge.
An edge? What kind of edge?
Better offering.
Better offering.
material.
There you go. What else?
Warranty.
Warranty, could be. Any other ideas?
That's longer.
It depends, it depends. Good thought. We went out as a company years and years and years ago saying, we don't want to do what everybody else was doing. We want to be bigger, better, faster, quicker turnaround. Everything was going to be better than what our competition was doing. So that's where it really kind of started, was let's do better than what everybody else is doing. Let's not just match what everybody else is doing, let's do better. Well, that was tough to do because it's 6.9% thicker. We have a lot of advantages of that. But what's one of the big disadvantages to it?
Weight.
Price. Cost, price. We pay 6% more for that product than your competition. So there needs to be an advantage, it needs to be something we sell, and sometimes we lose sight that we do sell something different than our competition. Some competition locally, other places has the same product, so it's not apples for apples. But for the most part, some of the bigger competitions like a metal cells, those type of a McElroy, it is a difference. And that's something we need to be sure that we are selling if we're paying for it. Because where does that 6% come from?
Or bottom dollar.
Bottom dollar, or if you're not getting increased margin, it's coming right out of the bottom. If you're getting the more pay, if you're getting more price for it, that's the reason you're doing it. So when you're trying to compare apples to apples, you gotta look, what is the apple, what is the orange, and they're not identical. So hey, I'm competing with this price and it's $26 a square. Well, what is it? So we're either losing some if we're matching it, or we're gaining some if we're getting more. But just wanted to say it's about 6% difference. And these prices, what prices were, what they are, that's changed all over. It changes every month, let alone when it did it. Yield strength, some terminology we're going to see on a couple of mill certs coming up. Yield strength, it's the point that steel begins to stretch. Tensile strength is the point that steel begins to fracture. What's fracture? You ever seen a piece of steel fracture on the floor? Because you bend a lot of stuff, hand bend. You ever see a fracture?
No.
Never seen a
I
fracture?
mean, I see a couple times, but,
What is it? What's it look like when it fractures?
well, it's,
Is it just kind of almost like a spider web all the way down through that piece where it bent?
well, yeah, in the paint.
In the paint, okay. So what happens if you get a fracture in that? What's going to happen?
Bro, I mean, the cars, you know.
It's going to corrode.
It's gonna weaken.
It's going to weaken it, but the corrosion's going to get in there. The paint's going to fall off. You're going to cause rust, that type of
Rust.
stuff. So we buy stuff at different strengths. Most of what you bend is a grade 50, so it's more bendable than the other, but it happens. And that's the point at which it fractures. Grade 80, our panel steel is ordered to a minimum of 80,000 PSI yield strength. This is our 29 and 26 gauge. Our 124 gauge is not ordered to an 80, it's ordered to a 50. Just so you all will know that. And then the commercial quality, we see this term CQ, some DX, things like that. It's a quality of steel sheet which can simply bend or undergo moderate forming. We do that for the trim purposes. Because you bend it, you gotta make sure it's flexible. Because if not, you try to go bend a sheet panel, it's harder, it's gonna be harder to bend, and it's gonna break, and it's gonna fracture on it. But you gotta have some flexibility. Here's an example of a mill cert. Any of you have ever seen one of these or not? But it's got some information on there that we ordered. I just want to throw out a few things. It's got the gauge. We ordered this one at 015 minimum, and that's going to be on the raw steel. And that's the grade 80 over here on the second one. Then down here, you saw the two terms we just talked about, yield strength and tensile strength. If you'll notice, that's not 80,000, is it? It's quite a bit higher, isn't it? Again, 80,000 is the minimum. Now, what if it's 120, 130? What happens then?
Can't bend it.
You get too hard, right? What happens if it gets too hard?
Breaks or
Same thing, same thing. And it makes it tougher on the machines that's roll forming it all the way down through it. Again, here's another one. This one is a trim type coil to class grade 50. But you see down here, your yield strength's 54, your tensile strength's 63. That's the trim product that you're bending every day out there.
So are the yield strengths and the tensile strengths offsetting? Like as one goes higher, the other one goes lower, or vice versa, or
This should,
not necessarily?
not necessarily. Not necessarily. I want to say yes, but that's not exactly right. This is an older chart, but again, I'm going to throw this one out here. This was scrapped from 2005 to 2010. 2008, do you know what happened? Crash. Crash, but what happened? What happened to prices of steel?
Went up,
Went up. But where'd demand go?
down.
Down. So what did scrap do? Shot up. So again, that's part of it. There's not as much being going. Just wanted to show you that that's got a correlation with what happens with pricing quite a bit too. It really does, your scrap. What is paint? Very basic. We're not getting into a lot of details with this one, but it's a mixture of pigment, resin, reduced to a liquid applied by a roller and used to protect, covering, or color a surface. So it's got pigment, binder resin, and solvent. Now, there's a lot of solvent it shows there. You know what happens to the solvent? Big paint guy, you know this one.
It flashes off.
It burns itself off during drying process. It's not well, so it's not left there. So you got pigment provides color, your resin provides the durability, and we use here an SMP and a Kynar for the most part. There is another product called polyester a lot of our competition use, and it's used for certain areas, and you're going to see a little bit about that here too. There's three types: polyester, siliconized, and then 70% PVDF fluoropolymer. What is that? You know what that is? It's a weird term. Long term.
Kynar.
Kynar. Easiest way to say it's Kynar. But that is the technical term of it. Polyester, it's a lower cost product. It is cheaper, but it's got good hardness and flexibility. They got a wide selection of colors, low, medium, high gloss, and acceptable corrosion, humidity, and resistance. But several of our competition, a lot of our form product coming in is polyester. What we go to is a siliconized polyester. Now what we use on that is a Valspar, which currently is a Weather X, and it's going to be changing to a Weather XL here. I'm going to guess in April, May, we'll probably start seeing more and more out of that coming in. And what they're just doing is they're developing, every time that all these different people are, we're trying to be better to our customers right now with service and delivery. Well, the steel mills are trying to make better steel last longer. Well, paint manufacturers are trying to perform even better by doing new paints to make our paint even better. So somebody said the other day, well, is the Weather X we got now not any good? I will tell you, the Weather X we got now is a lot better than what the SMP we had 20 years ago, 15 years ago, 10 years ago. So they're getting better with it. It's not that there's something wrong with it, they're just making it better and better. It's got a good fade and chalk resistance, the siliconized that we use, moderate cost, good chemical resistance, good corrosion, low to medium gloss range, wide range of colors, good formability, and good scuff resistant. Now when we come to a Kynar, it's going to have a little bit different. Like I said, good. It's excellent resistance chalk and fade, excellent chemical resistance, excellent post formability, excellent gloss retention, and excellent humidity resistance, wide range of colors, limited gloss range. Which one do you think costs the most? The Kynar. So every job has a difference of what it needs. So let's say we've got Farmer Jones over in Lincoln, who's got a barn out back. He needs to throw a little, he's had a little problem, had a leak on it. Does he need Kynar on that barn? No one's ever going to see, and it's probably, the barn's probably going to fall in before the roof will fall in? Probably not. Again, let's throw over here. Let's say we put a brand new Pizza Hut right up here on the corner, and they've got a bright red. Would you want to use a polyester that's not going to fade very, it's going to fade not as good, it's going to have different chalk. You want something that's going to be more long lasting. So there's differences for everything that goes on. And somebody asked me the other day, said, well, why would anybody ever use a polyester or something, even an SMP, on a big project like that? Why would you ever do that if it's going to be something you're really going to spend the money on? Well, one of the reasons that we thought about was, let's say you're taking over a building, you're only going to be in it for 3 years, and you're going to tear it down and build a huge Taj Mahal. Well, then that might be a reason you wouldn't want to spend the extra money, because you're going to tear it down in 3 years, and these are made to last long term. So there's always a case of something here and there, but it's really what the customer's needs are. and what they're trying to sell to the homeowner or end user. Conclusion, paint is comprised of pigments, resins, solvents, and additives. The quality of the paint, ingredients, and chemical technology are key to the product's performance. The best choice of paint coating depends upon the variety of factors, including in-use, color, gloss, durability, budget, because it is difference in cost, product life cycle, and environment.